So I will try to give an overview about IoT and how open source can be relevant. So first, bonjour tout le monde, je me présente. My name is Philippe and I'm working for a team in Samsung Research, which is only dedicated to open source projects. So that's, I'm a member of this team and I'm based in France, in Brittany. And I have a lot of interest into software, hardware, and community. And I am someone who is okay to put the hand in the mud and trying to fix things and so on. So if you have some issue with some software I'm presenting, don't hesitate to reach me. We can work together. So I will try to speak about IoT and compare it to the web and some challenge we are today facing, and to illustrate this with some demonstration. So yes, when you are in a very difficult context, you need to find simplicity. So IoT, the definition itself, it's a system of physical objects that can be controlled, discovered, and monitored. They are interacting each other on a network and eventually can be connected to the internet. But let's face it, internet is not mandatory, so I will explain this in detail. It applies to all kinds of domains, from agriculture to health, automotive, personal belongings, your smart home also. So you can guess there is a lot of skills involved. You have to know everything. That's almost impossible. It's come from hardware to radio to networking to power management, so many domains. So potentially a lot of issues. So you have to focus on one thing and trying to have a good team with other people to trying to make something really functional and also secure. So today I will try to explain. First, let's have a look about how the web and IoT are differing. So maybe I ask, do you know when the first IoT device was connected to a network on the internet? So it was not in year 2000, but in the early 90s. So there is someone who made a Coke vending machine, and he made this proof of concept. So that's funny to know that is what it occurred before the World Wide Web. So in terms of architecture, the web is quite easy because it's a client-server architecture. We have some three basic elements which you can try to build more advanced things, from HTTP, HTML, and unified resource location scheme. For IoT, it's totally different. You have a lot of different protocols, a lot of different contexts. So that's something which is trying to be standardized. That's a good thing. That's the same for the web. And in terms of hardware supporting device for IoT, you have everything from very low-end device to high-end devices. So that's you won't find a software stack that will run everywhere. So the bad news is that the good news is that it's already deployed. That we have near to 8 billion of devices on the market today, but we don't have many developers to develop them, so that can be a problem. If we compare to the web, it's totally the opposite. The web took over, but in a very longer term, and we have 10 million developers, or maybe more. So let's start with some challenge, and I don't have enough time, but I want to detail one feature or one value, because I believe it matters a lot. It's about the privacy domain. So privacy and security is something different. They are tied together. So we only focus on the privacy today. So privacy is about trust and control, and about data ownership. So what you need to know is that your personal data can be shared, can be logged, can be replicated, and if it's still personal, you should have the control on this. And hopefully now the European Commission established a new rule into personal data, and now there is a new obligation from cloud provider or service online provider and regarding personal data. So you've probably been spammed all the previous months receiving term of service updates and so on. So I won't go too far in detail in this because the text is quite difficult to read, and even for a software developer, it's not a specification you'll be able to implement easy. So how to do with this? So either we try to comply the regulation, or we try to do the things right in the first place. Instead of collecting data and trying to protecting it, maybe we can just avoid the collection and make a system user can use, have the same user experience, and without dealing about taking care of his personal data. In some cases, there is no value to do this. So let me try to explain this with a very simple example. Imagine you are renting a house for your holiday, and this is smart house. You have cameras in all the room of the house. Wouldn't you feel a bit uncomfortable? Of course, yes, because you have no idea who is watching you, so that's the problem. So if we want to, and you should be able to use all the smart house devices and make sure that only you can get access to it and control it. So we have two different people in this. This is a laser beam. No, where is it? Oh, there is none. Anyway, so in my example, we have two different roles. One is the house owner, and the other is a house renter. They are establishing a contract and decide to get access to the resource of the house. And once the period of rental is over, then you can, the occupier of the house can decide to unlock the house and give it back to this owner, and eventually reset the system to make sure his data are not used for any malicious use. So I try to implement this problem using Mozilla IoT Gateway. So let me show this. So this is my desk. It's a bit busy. So here is a Mozilla IoT Gateway. It's running on a Raspberry Pi. So this is the gateway we're supposed to support the house. There is some sensor, and here is my application. I can view all the device, and here is a fan I'm turning on with my remote control. So everything is running on a local network here. You can have access, remote access. Then I'm connecting a microcontroller, which is running on a ESP8266 microcontroller, and it's acting as a color light. So I'm connecting it to the system, and I can decide to turn on this in a local network. So I can change the properties of the device, and that's how it works. So this code is public. You can try it home. It will cost you maybe €5, so that can be fun for a weekend project. So this is a Mozilla Gateway, and now I made an HTML5 application running on Tizen mobile. So this is a web app, and it's also connecting to the gateway. So I'm showing you the how to register. This is only one time. For the first time you install the app, you have to log into your gateway and then retrieve the resource. So in my case, I'm using a local network. You can use a remote network also, because Mozilla is providing a back tunnel. Then, when connected, I can decide which resource I want to access. So if you're configuring the phone of your kid and you don't want him to have access to dangerous device of the home, you can decide to deny this. Once the resources are discovered, you can remote control them. So here is the same, the fan and the lamp. And I'll also attach to the gateway two sensors, one for the temperature and the other is for the bright ambient light sensor. So that's it. And then I can explain how it works in detail. So this is not very, there is no black magic involved here. It's very simple. So earlier we talked about the REST. It's the base of it's a very popular protocol in IoT. So from the HTTP get and post verb, you can create something more advanced when you have action on the subject. So The verbs are the HTTP verbs, and the action is the HTTP verbs, and the subject are in a URL. So if we look at my command line, first, this is address of the gateway, can be remote or local, depends. If your home cannot be connected to the internet, it should work also. And each things have a different endpass, and you can access to the property. So here I'm reading the property, and if I'm sending a put request, I will change the color of the light. So if you look in my green and red square, you see that I'm using different protocols. So using HTTP in a local network could be perfectly fine, but we can do better. The problem is that you cannot embed the HTTPS on a very small controller. So to solve this, the Internet Engineering Testing Force tried to solve this by adapting the HTTP and the REST using more constrained protocols. So basically, they are doing the same on UDP. Instead of serializing JSON streams, they are using binary, more concise. And this is the base of the IoT framework, which is open source software of the open connectivity specification. And this goal of this project is to try to provide seamless connectivity between devices. So virtually all the devices can talk together seamlessly. That's what we want to achieve. We have different sub-projects. One is for microcontrollers, and there is a node wrapper also, so you can use it from JavaScript. If you're not embedded developers, that can be easier for you. And something interesting is that there is also an initiative to define common semantics. This means what is a color, what is a on-off switch, what is a speed, what is all those physical element, how can be named in the same way, so then the device can talk the same language. So about JavaScript, it's very popular in some of our Samsung products. Okay, so JavaScript is a language that really was very successful in the web, and everything that could be written in JavaScript will be written in JavaScript someday, so that's something not to neglect. So the community is growing now. If you look at this short, the red line here is the number of NPM packages that's growing pretty fast. So I'm not talking about the quality, but about the quantity. And at Samsung, we made a port of, it's not a port actually, it's an implementation of a JavaScript interpreter for very constrained environments. So we have a JavaScript runtime on which is fitting in a very small amount of RAM, 64K, and you can put this on microcontroller as well. So that's pretty interesting. If you want to develop applications, you can write them in JavaScript, and you don't have to deploy over again the same toolchain and so on. So for software maintenance, it's quite prevalent. You can try it on a Raspbian and a Raspberry Pi also. Now to finish, just a proof of concept demonstration I presented earlier. So here I have an ARTIC development board. It's a Cortex M4 CPU, and I'm connected to it a LoRa gateway and a sensor, a LoRa antenna, sorry. So if I'm putting some gas on the sensor, then a notification is sent to the LoRa network. So all this demonstration was written in JavaScript using the Tizen OS and IoT.js runtime. So when this, we can make some very funny. So here is the details of the software. So I'm using a LoRa chip from Microchip, which is very easy to integrate, and then now I'm showing some trace, so it's trying to connect to the network. I was hiding my keys, and in a few steps you get connected to the network. So don't keep in mind we are not doing a fiber channel here. This is a very constrained bandwidth, so you don't think about using LoRa as a replacement of Wi-Fi. This is not the same technology, so it's based more the size of SMS you will send each day, of maybe a couple of times a day, no, not more. So now we can do on this demonstration is trying to get the position about this sensor, what was where was high when there was this presence of a dangerous gas. So to do this, we can do this using another device. So there is the last time I'm showing the demonstration. Okay, this is technical, so I can skip it. So yeah, I tried to put it on a bicycle on battery. It's working. And to get the position of the place, I'm using a phone with a GPS. And to connect to the system, I'm using the IoT framework, which is the server is on the phone and the client is on my development board. So that's a very rough proof of concept, but it was possible using all the project I explained before. So yeah, the server is running on the phone, and you'll see the client running on the development board. It's running on Tizen RT, and so you have the discovery of the resource, and then the value is updated. So we can move forward then. So last slide. So I explained about IoT and web, and there is a convergence between people from the web and people from the IoT world who are trying to make something more integrated. This means we can link the web and the IoT more easily using the web technologies. So I talked about REST before, but we can do a bit more than that. We can add some intelligence to our things by deploying scripts on devices. That's a possibility. A description of data is also an important topic. So we have the OW2con'18 consortium, who is trying to publish and push the Web of Things specification, and Mozilla has another proposal, which is more simpler. I know a bit about it. And the next challenge is trying to align on the semantics, because there is no need to overlap. So that's something you should care about. But please don't try to reinvent the wheel. If there is something specified in the open source and open standard, you should care about this, and you will not pay a technical debt in the future. So in summary, we have a massive adoption of the web. We have a very heterogeneous Internet of Things. So today there is a lot of silos, and we can break this if we are working together trying to build this Web of Things and reduce the complexity of embedded development for application developers who are comfortable on the web today. So that's the next challenge. I believe that privacy by design is something that should not be ignored by if there is the success of IoT probably depends on this. And there is so many projects you can evaluate, so feel free to join. And if there is something I'm missing, don't hesitate to tell me. Something I'm looking for instance, is how to implement GDPR rules in a generic way. I have made some research and I didn't find any. So you have some? Okay. So now I have some resources. I'm open for questions, and if you don't have, if I have time, I will show you one more video. That's all.